Now we have understood some very important constructs that could be used in Python programming language. Let's move on to another important topic, which is essentially how to use core libraries in Python. One of the very important libraries that are very widely used in scientific computing is Numpy, and it provides essentially capabilities for storing multidimensional arrays and performing different operators on those arrays. So let's see how we can use a core library that is there for you to use, and NumPy being one. The first thing that you need to do is essentially, in order for you to use any library, you have to import that library. And import is a essentially allows you to use a set of library that has been provided by in the programming framework, in Python programming framework that is out there. So here, what I'm doing here is I'm importing NumPy library to my code block, and once I have imported that NumPy library as NP, I can start using the different functionalities that are there in the NumPy library out there. So first you need to execute this import NumPy as NP, and that allows you to access different functionalities that are there in the core library NumPy. So after that execution, I can do multiple different things. For example, I can define 1D array, which is 1, 2, 3. So now np.array, which is the variable that how I'm importing NumPy, and I can now use to do operations on NumPy using NumPy library that is out there. So now I'm defining an array A, which is essentially using NumPy.array function to create an array. I can print out, the type of A, and you can see that the type of A is defined as numpy.nd array, n-dimensional array. That's the type. It's not anymore, a list, or it's not essentially an integer and so on. Essentially the type of A is dependent upon the numpy library that is out there. Okay. If I want to check the shape of this, you can see the shape of this is 3 comma. Essentially this you have 3 elements, and that's what has been represented by shape. So you can use the shape command to find out the shape of this variable that you have declared. If you want to print out the first item of the array, then you essentially do 0 indexing, because remember, indexing starts with 0, and that's how you can access the first element. So if you do A and square bracket 0, then you will have the ability to print out the first element of the A array, which turns out to be 1, and that has been printed out. What if I want to print out 2 items in the array, right? And again, similar to list, which we have shown previously, what we can do is we can do this A square bracket colon 2. So that will allow me to print the first 2 items in the array that we are storing, and that's how we can print this out. So if I run this, you can see that I'm printing out 1 and 2, which are the first 2 items in the array A, and that's how I can access or print them if needed. If I want to define a 2-dimensional array, right, I can use the command that is right here, where I'm using 2 different square brackets. So you can see square bracket, first square bracket is storing 1, 2, 3. The second square bracket is storing 4, 5, 6. And both of this are stored inside a square bracket. And this is the syntax that you will use to essentially define a 2-dimensional array. Now, if you want to check the shape of this 2-dimensional array, you will see that the shape of this is 2, 3. So the number of rows are essentially 2, and then the number of columns in this array is 3. That's why you will see this shape, which is 2, 3. Okay. If you want to print out, the first row of array, then you will, essentially use this command that is given here, which is you have B square brackets 0 comma semicolon, which is essentially all the elements of the first row. If I do that, I can print out 1, 2, 3. Okay. And similarly, I can run this one, right? B0. If I want to print that out, all the array 1, 2, 3 will be also printed out. What if I want to print the last column of the array? Okay. So remember, -1 is an important trick that could be used to access the last element of the list. Similarly, in Numpy, you can also use -1 to access either the last column or the last, row of an array that is here. But in this code block which I'm executing right now, we are essentially accessing the last column of the array B that is out there, and you will see in the last column we have 3 and 6. So if I go back here, you will see 3 and 6 were essentially the elements that were there in the last column. And if I want to access 3 and 6 of the last column, then I can do this command b square bracket colon minus 1. I can access the last column that is out there. What if I want to print out the first and the last column of the array simultaneously, right? So I can do that using the command that is given here, which is b square bracket within the square bracket colon comma, and then I have another square bracket 0 and 2, which allows me to access essentially the first and the last column, okay, and print out the values that are stored in that array for the first and the last column. And you can see that using this, we can print out 1, 3, and 4C. What if I want to modify the value of a specific item in the array? So I can go to that specific location and I can change the value of that item that is out there. So if I want to change the value of the item which is on the row 1 and column 1, I have to index. Since the index of that will be 0, 0 in Python, I can use this command which I'm going to execute right now, which is b within the square bracket 0, 0 is equal to 0, and that will allow me to essentially change the value that has been stored in the array at first row and the first column. And using this, I can essentially change and modify that. What if I want to access and find an item which has a value greater than 3, right? I can use b is greater than 3, right? And I can find out all the locations where this is true or not. And similarly, I can use a similar command, which is b greater than 3, and that will allow me to access the elements where the values are greater than 3, which is 4, 5, and 6. And so these are some of the tricks that you can use to access different arrays values and and change different arrays value defined in Numpy. Let's move on to another important concept which is related to array math. So how to do math operations on array elements that we have. So let's begin with this code block, which is basically defining two-dimensional arrays in variables x and y's, and we are using basically np.array command to create these two matrices, which has the first one has the first row is 1, 2, and the second row is 3, 4. Similarly, y has the first row 5, 6, and the second row is 7, 8. As you can see, the dimension of the matrices are 2 by 2. Now, if I want to do element-wise operations, and if I want to sum individual element each corresponding to specific rows and column numbers in each of those matrices, then we can essentially carry out those operations using np.add, lt.subtract, np.multiply, and so on commands. And the np numpy library allows you to do those specific types of operations. So if I want to do an element-wise addition, which means if I pick the first element, which is located at row number 1 and column number 1 of matrix X, and the first element of matrix Y, which is row number 1 and column number 1, and if I want to sum them together, and similarly I want to add the specific numbers which are located at different location in the matrix element wise itself, and not do an operation on the whole matrix, but just take those specific element in each of those matrices and sum them together, then I can use this command, which is np.add xy. And if I run this, you will see what this operation is. Essentially, this operation results in adding the element wise arrays. So if you look into U1, which is the first element of array of matrix X, and if you look into the first element of matrix Y, which is 5, if I add 1 plus 5, that is 6, and that is what is represented as an output of this element wise sum we have. If I take the second element of matrix X, which is 2, and the second element of matrix Y, which is 6, and add that up, this is 2 plus 6, and that's why you see the second element in the array, which is output of the command np.add, is essentially 8. So essentially it is picking each individual elements in both the matrices and just summing them up, and that is resulting in a resultant matrix, which is represented by, or which is encapsulated or captured by this np.add braces x comma y. Essentially, that's another matrix. Similarly, if you want to do element-wise subtraction, so if I take each specific element on a matrix X and each specific corresponding element in the matrix Y, and I want to subtract that element-wise, not the whole matrix, then we can do that using np.subtract. So let me execute this command, and you can see what it is doing is, first, in order to generate the first element of this np.subtract xy, it is taking 5 of y, right? It is subtracting 5 from 1, which is the first element of y from the first element of x, and that is resulting in -4 value, and that's what you see as an output. So if you take that, each of the corresponding, and subtract them, it turns out they turn out to be equal to -4, -4, and that's why you have all the values in np.subtract output as -4, -4, and so on. Similarly, you can take individual element of matrices X and Y and multiply them together. Okay, so since you can do addition and subtraction, this is a relatively becomes an easy operations where you take the first element of X and multiply that with the first element of Y. So 1 times 5, that will be 5, and that's what you're seeing. Similarly, if you take the second element of X and second element of Y, which is 2 and 6, and you multiply them together, that will result in 12, and that's why you see, at the location 1, 2 of the np dot multiply braces X comma Y, you have 12. Okay, so it's essentially doing element wise multiplication. It is picking that element of X and picking corresponding and same element in Y, multiplying them together, and then storing that, right? And so this is what is the element wise operations that you can do. Similarly, you can perform element-wise divisions, which will basically take the corresponding elements in X and Y and divide them. And that's why you see here a value of 0.2 in the first location, because you're dividing 1 by 5. So the first element in the matrix X is 1, the first element in the matrix X is 5. If you divide 1 by 5, you get 0.2, and that's what is representing. And similarly, you're doing the other operations on the other elements of the matrices X and Y, and you're getting different values, which is represented by this np.divide braces X comma Y. You can also perform operations like square root, and so what we are doing here is we are taking the matrix X and we are now performing a squaring root of each of the individual elements. If I want to do that, I took a matrix X and I exponentiated that 2.5, which is equal to square root, and then in that case what it does, it is basically takes the individual element of the matrix X and takes the square root of those elements, and we get the output for this command, which is listed here in the form of np.sqrt braces X, and you will see, since we are taking a square root of 1, we are getting a 1 as an output. And similarly, there are other values, which is essentially taking the square root of the other elements that are present in the matrix X. Okay. Now, similar to taking element-wise, operations where we can subtract, addition, multiply, divide, and take exponentials and so on, we can also use, dot functions, which are to compute the inner products of the vector or to multiply a vector by product using np.array. So here, what we have seen is we have defined, two different two-dimensional arrays, right, that you see here, which is X and Y, and I can take a dot product, which is like matrix product, and if I multiply and take that dot product, we will get this corresponding output, which is shown by this value of 19, 22, 43, and 50. So these operations are not element-wise operations. These are essentially dot product of two different matrices, and if you want to do that, then you have to use np.dot braces X comma Y, which multiplies two different matrices together. Okay. Similarly, if you take X dot Y, right, so that will allow you to essentially generate the same thing, which is essentially take a dot product of matrix X with the dot with Y. Okay. Now the same thing could be repeated using this X to the or at rate y. This is another way of writing the same thing. Okay, so there are three different ways you can write this dot products, which is np dot dot braces x comma y's, or you can do x dot braces y, or you can do x at the rate of y, and all of this essentially allows you to take the dot product of two different matrices or allow you to multiply a vector with a given matrix. Similarly, you can also do some other operations. For example, if you have a matrix and you want to transpose or get the transpose of that matrix, then you can do x dot t, capital T, and that will essentially convert and give you the transposed matrix of x, right? You can also do reshaping, which is an important function in many data science and machine learning algorithms, where you want to find out you want to basically take a matrix and resize that and reshape that in some other matrix dimension that might allow you to multiply different matrices based upon the different operations that might you have. So in case if you want to use the reshaping operations, what you can do is you can take the matrix and you can reshape. Just for example, if you take x and you do x dot reshape braces 1 comma minus 1, it will essentially reshape that matrix into a row vector. Now similarly, if you do reshape in a slightly different way where you do minus 1 1 instead of 1 minus 1, then essentially this will create a column vector. Okay, and so these are other different ways of reshaping and creating a vector out of matrices and stuff like that. And this is an important operations in many machine learning and data science applications that you might have. So these are some examples of how you can use different functions in Numpy that is existing to do element-wise array math, which is like subtraction, multiplication, element-wise. If you want to multiply two different matrices, then you have to use dot, right? np dot dot. If you want to do transpose or reshaping, then there are specific functions in Numpy that allows you to do that.